Hi everyone. In this video I am going to continue with the topic that is D and F block elements. So another property related to D block elements is catalytic property. In last video we have seen about few general properties of D block elements. Another most important property of D block elements is catalytic property. That means they can act as catalyst. So what is meant by catalyst? It is a substance which do not participate in the reaction but alters the rate of reaction. Alters in the sense it can increase the rate of reaction or decrease the rate of reaction. So whatever the organic substance or any substance is having the property either to increase the rate of reaction or to decrease the rate of reaction, then such type of compounds are known as catalyst. Okay, so here most of the D block elements can act as catalyst. So one of the best example is that hydrogenation of alkenes to alkane or alkynes to alkanes. So hydrogenation reaction is best example of catalytic reaction. In such type of reactions we can use nickel or palladium as one of the catalyst. So both nickel and palladium belongs to D block elements. Okay, so due to containing two important reasons they can act as catalyst. So one of the example, hydrogenation of alkenes and alkynes. It can be done in the presence of nickel and palladium. And another most important one is that manufacture of ammonia. So we know ammonia can be manufactured by using Habers process. About this we have studied in P block elements. Okay, Habers process is used to manufacture ammonia. So this ammonia can be manufactured by using nitrogen gas and hydrogen gas. When these two gas are undergoing reaction in presence of iron oxide as a catalyst, it can lead to give bulk amounts of ammonia. That means here iron oxide is not participating in the reaction. Okay, but we are using it. Why? To improve the rate of reaction. Okay, in general nitrogen and hydrogen gases are very less to undergo reaction. Whenever we use this iron oxide, it can speeds up the rate of reaction between the nitrogen and hydrogen. That means here iron oxide is acting as catalyst. Even this iron is an example of D block element. Okay, and even we can use platinum and vanadium pentoxide in the manufacture of sulfuric acid. H2SO4 can be prepared by using contact process. Even about this preparation we have seen in P block elements. While preparing this H2SO4, we have to follow three important steps. In that we can use platinum or vanadium pentoxide as one of the catalyst. So both platinum and vanadium, these two are the elements related to D block. Okay, so that even we can use them to prepare sulfuric acid by using contact process. So here you may get a doubt that why all these D block elements can show this type of catalytic property. So due to two important reasons they can show this catalytic property. That is, first one, it exhibits variable oxidation state. Okay, in general properties we have seen about this variable oxidation state. What is meant by variable? Many. So that means they can form different types of oxidation states. Due to having such a property to show different oxidation state, it can act as catalyst. That is one of the reason. Another reason is that they provide more surface area for the adsorption of reactant molecule. For example, here we have seen about manufacture of ammonia. Here two reactant molecules are undergoing reaction, that is nitrogen and hydrogen. If they wanted to undergo reaction, they need some area to participate in reaction. Such area is now given by iron oxide. Okay, so surface area provided by iron oxide. Upon this iron oxide, now these two are undergoing reaction. So that means here this iron is providing some surface area to absorb nitrogen and hydrogen molecules. Whenever they absorb on the surface of iron oxide, they started to undergo reaction. Then they build some bonds between nitrogen and hydrogen. Whenever the bond between nitrogen and hydrogen becomes stronger, then immediately they will escape from the surface of iron oxide, and then it can give again space to undergo reaction for few other nitrogen and hydrogen molecules. That means surface area is now provided by the iron oxide, which is nothing but one of the D block element. So due to having more surface area by this D block element, even they can act as catalyst. Okay, only two reasons to show this catalytic property, that is exhibiting variable oxidation states. Next, providing more surface area for the adsorption of reactant molecules. So this is very important for 2 marks. So what are the two reasons to show catalytic property by the D block elements? The two reasons are variable oxidation states and providing more surface area. Okay. Now another important property we are moving, that is formation of interstitial compounds. So first we want to know what are interstitial compounds. If you say any type of solid compound, okay, so here compounds may exist in solid state, liquid state or gaseous state. Understand? Here I am taking one of the compound which is existing in solid state. So in solid state, all the molecules or atoms are attached in a specific manner, and between the atoms we can see some space. Okay, between the atoms, though they are tightly bonded with each other, some spaces are left over between the atoms. Such spaces are known as voids or interstitial sites. About this we have studied in solid state chapter. Okay, some voids or interstitial sites are created in solid state atoms. Now these voids or interstitial sites are occupied by the small atoms such as carbon, hydrogen, boron and nitrogen. But these are non-stoichiometric. That means they don't have any definite proportions. Okay, so they don't have any definite proportions. That's why they are non-stoichiometric. So that means here solid state molecules are providing some interstitial spaces which are known as voids. In such voids, carbon, hydrogen, boron, nitrogen, like small atoms are going to arrange in non-stoichiometric ratios. So here we can take this solid which is made by vanadium. Vanadium is one of the D block element. When such vanadium voids are filled by hydrogen atoms, it can give VH type of interstitial compound. So with the proportion 0.56. Okay, just now I have told you they don't have any definite proportions. Okay, so that's why here it is in 0.56. Sometimes these atoms, whatever are involved in the solid state, are now with manganese. So this manganese is also one of the example of D block element. So such manganese solid state compound is now containing some voids. Such voids are now arranged by the hydrogen or occupied by the hydrogen, can give manganese hydride. Okay, so this manganese hydride is also one of the interstitial compound, because it is made between one of the D block element and smallest atom present in the periodic table. And another one is that even iron is a D block element. Iron solid voids, this is iron, just imagine if it is a iron solid. So this iron solid voids are also occupied by the small hydrogen atom which is known as iron hydride, like titanium carbide. So all these, whatever I have written here, examples of interstitial compounds. All these interstitial compounds are containing one of the metal and the smallest atom. So then those are known as interstitial compounds. Okay, so if we compare the properties of interstitial compounds with the normal elements, these interstitial compounds are containing high melting point, hard and rigid in nature, and they retain conductivity. So however the metal elements or normal elements are conducting electricity, even they can conduct the electricity. These are the three important properties of this interstitial compounds. Now final property of the D block elements is that formation of alloys. Even homogeneous. What is alloy? First we want to see. It is nothing but one of the homogeneous solid mixture of metal with another metal or non-metal. So compulsory it is containing one metal. A combination of metal with another metal or metal with non-metal is known as alloy. Homogeneous solid mixture of metal with another metal or non-metal is known as alloy. So these D block elements can combine with different types of other D block elements can form different types of alloys. Example, whatever we are using in our home, that is stainless steel. So that stainless steel is a combination of iron, nickel and chromium. Okay, so these three are D block elements. Here iron is combined with another D block element and can exist as a stainless steel. Okay, bronze and brass, these two also we know. So they are combinations of copper and tin, copper and zinc. These two are also metals. The mixture of these two metals are known as bronze and brass. So all these are combinations, homogeneous solid mixture of metal with another metals. Okay, the reason to form alloys is that almost having the same size of transition elements. All transition elements are examples of D block elements. Understand? So all these transition elements are containing similar sizes. Due to containing almost the same sizes, they can involve in the formation of alloys. Why they are making these alloys? So to control corrosion, okay, as well as to improve their elasticity and other type of properties, they involved in the formation of alloys. Okay, so these are the few important general properties of D block elements.